Now we're going to solve for an equation that uses some numbers that they're asking you to plug into the problem. Remember, the first thing I have to do is I have to write an expression. To write my expression, it is the reactants are given here, and coefficients are these little numbers, and you're going to look at your states of matter, and products are given here, and these are the coefficients. So it is your products raised to the coefficients over your reactants raised to the coefficients. And the little brackets mean the concentration of. So that's the template that I have to look at. The first thing I have to look at is to see whether or not my states of matter will make it to where it stays in the problem. And the second thing I'm going to look at, and I don't use anything that is solid or pure liquid. And the next thing I need to do is make sure I balanced my equation, because I'm going to need these coefficients. So let's look at the problem at hand. And the problem that we're looking at is this one. So the first thing I have to do is balance the equation. And I'm also missing a state of matter here. Let's put that state of matter in. So the first thing I'm going to do is balance my equation. So I've got two H's, and on the other side of the equation, I have 6 H's. Okay, so 2 H's on one side and 6 H's on the other side. So since it's in two different places, I am going to leave that to last. I always balance things that are in more than one place till the end. So then let's look at our C's. I've got 1 C and I've got 1 C. And I've got 2 S's, but I only have 1 S. So if we would have balanced our H's, I would be messing my H's up again now by balancing my S's. So I put a big fat 2 in front of the S. Now everything is balanced except for my H's, and I can go back and balance those. So on this side I just have 2, but on this side I have 4 and 4, so I have a total of 8. So in order to balance this, I need a big fat coefficient of 4 out in the front of there. So I balanced here with a 4, 1, 1, and a 2. The next thing I'm going to look at is I'm going to look to see if the states of matter are liquids or gases, because they're not going to end up in my expression. So that's a gas, it stays. 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 So remember, I am going to make a expression based on this template right here. Okay, so they were all gases in my equation, so I'm actually going to be using one that says Kp, but you'll notice it's pretty much the same thing. The difference is they just say pressure of that instead of just the concentration of it. So I'm going to plug in the products raised to the coefficients. So in my equation that I had here a second ago, my products are CH4 and the coefficient is a 1. And my other product is an H2S and my coefficient is a 2. Over my reactants, that's the H2 raised to the 4 and the CS2 raised to the 1. I got my coefficients from in front of each of my compounds here in this equation. Now, this particular problem is asking you to substitute in numbers for the different aspects. They've given me the K. So in the spot where the K is, I'm going to put in 0.0246 because that's the number they told me was for the constant. Okay, and then I'm going to plug in the CH4. That number for the CH4, I go look for it, is right here, 0.00108. Then I'm going to plug in for the H2. That's what I'm trying to find, is the H2. So the H2 ends up being my variable in this expression. And then I'm going to go find the H2. So according to this problem, my H2 is 0.0316. And then my my pressure of my CS2, so I go find my CS2, and it's a 0.0898. So once I have substituted in all of my numbers, which I'm solving for H2, my numbers are going to sub in the equation like so. Okay? So now all I have to do is some algebra 1. I need to isolate this x. I got to get that x all by itself. So lots of things are keeping that x from being alone right now. One thing I have to do is I have to clear the bottom. In order to clear the bottom, I have to multiply both sides by the pieces that are on the bottom, and of course then these will cancel out. So when I multiply the bottom of this equation by those two numbers, I end up getting those two numbers times 0.246 equaling the stuff that was left on the top and my x. Okay? Then I have to still get x alone. So what's keeping x from being alone? That guy is keeping x from being alone. So both sides of this equation have to get divided by the 0.00108. So now my equation looks like this. Both sides get divided by 0.00108. That leaves x to be x squared. That's still not alone. So when I do my calculations for this, I get all of this right here equals 2.0396 times 10 to the negative 5, and that equals x squared. So how do I get rid of the squared? I take a square root of both sides, and that is what's going to make my answer equal 0.004516 or 4.516 times 10 to the negative 3. So this is my final answer after I plug and chug into my equation. And that's all there is to it. Just isolate your variable, and then you can solve for your equilibrium expression for any aspect that they are asking you to solve for.